decreasing. So this is one which we discussed yesterday, that the Ithorne's triangle and the Wilson's terminal and the not using Wilson's terminal in AVF, AVL and AVRY. So here we will more focus on the axis of the cardiac axis, how it is formed and why the axis is required. Not much that you should know what is the degree of the angle which the patient ECG is on, but you should know how the cardia is rotating or the way the position is and what are these pathologies which are causing the cardia to depict in the ECG in a similar way. So here we know that lead 1 is the right upper limb and the left upper limb. Obviously the left is always the positive thing, so in the lead 1 the left upper limb is the positive. So lead 1 is, so you bring it to the cardia, the central position is like this, and lead 1 will be in the left upper limb. So usually the QRS will not be that much big, because most of the impulses will come, the ventricular impulses are coming slightly down, but still slight impulses are there. But it is not that there will not be a very big R, but there will be a isoelectric phase, like there will be a small R and there will be a small S. That means both the R and S are equal, because the half of the conduction is coming through it and half of the conduction coming down. So S is deep and a bit of R. So what happens when the cardia shifts or cardia rotates, when the LVH is there, when the aortic stimulus and big LVH is there, HCM is there, then the things get turned out, like the cardia is shifting upwards and the ventricular is getting hypertrophy towards the left chest cavity. Then these R waves goes up, because the positive in the left upper limb goes up. So then you are going to get the point that rather than lead 2, the lead 1 is showing more of the bigger R waves. Then you are suspecting that left ventricular pathology is there. In a turn, in the actual ECG or the doctors or the cardiologist words, it's the more left axis deviation is going to happen. So after lead 1, the lead 2. Lead 2 is the absolute normal ECG, because the lead 2, if you get it centrally, it runs through the heart, runs through the cardiac axis, through the axis of the cardia in the left cavity. So the R will be big, the P will be good and T will be good. That is what is normal axis is called. And then coming to the lead 3. Lead 3 points towards the left leg. Left leg is positive and the left arm is negative. So whatever, if the terminal is more and more right ventricle is getting active, like right ventricular hypertrophy, pulmonary hypertension, right ventricular infarction, so all those is among the syndrome in congenital heart diseases, all those pathologies where the RV is going to have a bigger hand will get positivity in the lead 3. In the sense, it's more getting towards the right axis deviation. So simpler, if you are taking it the bipolar leads, lead 1 is very big R, go with left axis deviation. Lead 3 has very big R, go with right axis deviation. So simple. Then coming to the AVF, AVL and AVR. As we know, AVF points towards the positive. It has no bipolar loads, so all other leads are actually grounded. So grounded are, so whatever the positive thing which is coming, like AVF should be positive when the right things are there. Like lead 3 and AVF are going in a hand in hand. When we see this, the lead 3 and AVF are going more hand in hand. So AVF is more and more posterior, inferior and right prominent. Whatever the right pathologies are there, posterior pathologies and inferior pathologies are there, you will be getting a very good positive R wave in the AVF. That means the axis is more and more towards the right axis. So AVL becomes more upper than the lead 1 which we have seen here. That means it is more 30 degrees upper than the positive towards the left upper limb, and because there is no minus and plus here, you see the minus and plus here, but it's only the plus, the effective amplitude whatever is coming will go to that direction. So if the heart rotates still further, like the LVH is severe, like the antero wall MI is there, like LBBB is there, in those conditions, the more and more the impulse will be going towards the AVL, and AVL will be forming a big R wave, but usually it will be the negative S is the more commonly seen, because the impulses are coming towards the left leg. And AVR is the one lead which I already told everything should be negative, because here the positivity is in the right upper limb where the cardiac conduction no way goes around. So all the waves should come in the negative direction. If it is coming positive, then you should be thinking something where all the conductions are going in the opposite direction. Then the severe triple vessel disease, subendocardial ischemia, left main coronary artery disease, all those things like the VT, where the impulses are coming from the apex to the upper part of the ventricle, those conditions you will get a AVR elevation or AVR positivity. Or other thing is that if you change the lead system, like if you change it from here to here, then obviously AVR will be positive. If this becomes positive and this becomes negative, or this becomes positive and this becomes negative, then all the conditions AVR will become positive. Okay, similarly now coming to the axis which I already discussed.